are going to be in the building. But we also have a couple other things included. The copy constructor and the destructor. Together, they make the big three. If you have not implemented any one of these, the constructor will do this for you when you compile it. So I haven't done it in apartment.h. We only have the two regular constructors. So if later in, and I will do this, if later on I go ahead and I try and make a copy of apartment.h, well, an apartment object onto a new apartment object, it will take care of that for me. And I can do that specifically because I don't have any of this in there. Dynamic memory. This is the whole reason why you have to implement it yourself and manage your own. Because, like we said before, dynamic memory is managed by the user, not by the system. So, copy constructor. Why would we need a copy constructor first? Because if I am making a bitwise copy of an object onto a new object, and that object has pointers to dynamic memory, which we do, the new object is going to point to the same location in dynamic memory. So if the original object is deleted, that dynamic memory goes bye-bye, and our new object still points to the dynamic memory, which is now garbage. We're in a memory leak, so we need to avoid it. The destructor. Now, this is the favorite of mine out of the big three. So, this is generally called only on its own. You don't have to actually call this ever. You'll never directly call it. Note the syntax, the tilde, and it's just tilde, class name, parentheses. So generally it's going to call when the program's exit, but say I have a dynamically allocated building object, it'll go ahead and destroy it. It'll call the destructor when I try and delete that object. So, then I have several regular functions for playing with the private members. And note I have a reference to a apartment object. So that can be fun later. Well, we'll see how fun that is now. Jumping over to building.cpp. So, now that we're working with dynamic memory, we have to be rather careful in how it's implemented. So, for my apartments, remember this is a dynamically allocated array of pointers to apartment objects. I know it's really heavy statement, but when you think about it simply, you're making a array. This is a pointer to it that is going to be a dynamically allocated array of whatever size we want, and each element of the array is going to point to a different apartment object. So when we make a default one, which is our standard constructor, it'll be of size X. We build the array and then fill it all with null. So we know where everything's going. It's not garbage. So the copy constructor, a little more entertaining. See how we pass copy object. Now, objects of the same class can access each other's members directly. Therefore, copy object dot mySize is going to be able to assign right over to mySize. And the same way for here, we declare our new array Same way up there. And then for the for loop, each single member of the original myObjects is checked. If it's null, we just set ours to null. If it's not, we have to make a new apartment object, and here is where the magic happens. We are calling the copy constructor of apartment, which we did not allocate or did not declare at all in apartment. The constructor is going to do it itself. It's going to take this dereferenced apartment object and just do a straight bitwise copy of it over into here. It's that simple. So we have our very loaded array of dynamic objects, and now we have to get rid of it. Deleting that is simple. Is a for loop each time for each part of the index of my apartments. We have to deallocate any memory that's there, and then we can delete my apartments. It is an array of dynamic memory. So all the memory that's allocated by the dynamic memory by the pointers that are dynamically allocated need to be deleted. It seems so crazy to say it out like that, but when you look at it, okay, delete everything in the array, then delete the array. Easy. Let's see, one thing I wanted to point out is, yes, here we have our object of apartment, and how do we set in our new add apartment is the same way as before. We reference our past apartment number and call the existent / non-existent copy constructor for apartment. And it should be about it. Most of this other stuff is pretty simple. Yeah. So let's make one last note before I jump over to the compiler end. This is just a main that I wrote up. You can browse it later if you really care. I have building my building. What this is going to do is create a building object called my building of size 4. See how we pass parameters the same way you would with a function into a new object. So what this is going to do is immediately it's going to call the basic constructor of just an integer for my building, well, for the building class, and make my building. And then we can reference all the members of the public end of the class using the dot operator. So my building dot print all will call the print all function for the building class. And I use several instances of creating new apartments and adding them and messing with them and removing them. But you can really get a feel for how these functions work within the class. So let's jump over the compiler end and make sure our make works. Okay, so here is our compiler side of things. Notice we have all of the files from our demonstration in here, especially including the make file. And it just does everything for us, basically. It's gone and built our executable, done all the linking and everything for us. So there we go. Now, if I wanted to make it again, it's going to check all these files and notice, okay, I didn't change any of that, so it's up to date. it's all good. So if I wanted to just fully remake it, I would just do make clean, which would get rid of all of the files, and remake it, and there it goes. So that's your tutorial on basics of classes and Makefile. Hope you enjoyed it. If you have any questions, again, hit me up on IRC or the forums. This will all be up on the show notes. It'll probably just be in a big pack, because I don't even want to think how messy it would look having to put all of these files up individually. So, good luck, happy hacking. Later, guys.